Here in example 1, we're looking at a function, an exponential function here, which we want to graph. And we'll begin by identifying the asymptote, which, as always, is going to be the d term. So in my step number 1, I label the asymptote y equals 8. And to expedite things, I'm going to graph it as well. So that's going to be a horizontal line through 8. There it is in red. And again, to emphasize the asymptote aspect of it, I'm going to do a broken black line. So there we go. Our basic table is, in this case, our base is 3, so it's going to be y equals 3 to the exponent x. And I'm going to choose the values -1, 0, and 1. So this will give me 0.3, this will give me 1, and then I will get a value of 3. So step number 2, I multiply the y values by a. In this case, my a value is -2. So what I'm going to get is -1, 0, 1, 0.6. I'm going to get -2, and I'm going to get -6. So the y values are multiplied by -2. In step number 3, I'm going to add to the d values. I'm going to add the d values, which in this case, my d value is equal to 8. So I get, how do I get here? 8.06. Actually, this was negative, so that's not right. It will be 7.4. I will get a 6, and then I will get a 2. So what my graph looks like, roughly, my y-intercept is 0, 6, so I'm going to have a value here. When x is 1, my y value is going to be 2. And then for -1, it'll be very close to 8. So my graph looks something like this. There's one end and there's the other. My y-intercepts, well, we already said that was 6 from here. The x value is 0. My asymptote, we said, is y equal to 8. My range is all real numbers such that y is less than 8. And my domain is all real numbers, no restrictions on the domain. The function is, in this case, decreasing. And the reason why is because if you look at the graph, the values of y are continuously going down, okay? So that's a decreasing function. And finally, I've listed there for you the transformations. Reflection on the x-axis, stretched by a factor of 2, and a shift up 8 units. And there is your first example. For example number 2, I'm looking at a similar function, except that my base this time is not 3, but I have a 1/3. So first things first, identify my asymptote, which is the last term, and that's going to be y equals -7. And for my table of values, actually even before I do that, let me just graph that in. Here it is, y equals -7. And if I do a broken line, I get something like this. My x values are -1, 0, and 1. And my y values for a third are going to be 3, 1, and 0.3. So next, I multiply my y values by a. So I'm going to get -1, so that's multiplying everything by 2. All the y values times 2, so I get 6, 0, and I get 2, -1, and I get 0.6 repeating. And finally, I add 7, or -7, because my d value is -7. X values stay the same, and I get -1, -5, and repeating, roughly. So let's take a look at what these points are going to be on our graph. So -1, -1 is going to be back here. 0, -5 is going to be over here. And oh, there's a mistake here. It should be positive, positive. And finally, +1 is going to be -6.4, which is roughly, again, over here. And if I trace out these points carefully, I get a graph that looks like this. Again, I don't care about the exact form of the graph. I'm more concerned about, the y-intercept and the general shape. Make sure that it approaches the asymptote, you have arrows on the ends, and that it's going in the right direction. So our y-intercept here is going to be -5. The asymptote y equals -7. The range is everything y such that y is greater than -7. The domain is all real numbers. And the function is, in this case, well, the y values keep on going down, so the function is decreasing. So I'll write decreasing here. Transformations are listed there for you. Vertical stretch by a factor of 2 and a shift down 7 units. Pretty straightforward. In the next lesson, we're going to look at horizontal compressions or stretches as well as horizontal shifts.